This video is to show the preparation of data um, that is required to use pyNITA, or at least the common way that we recommend doing it, in order to get a set of sample points at locations that you hopefully know pretty well, or have some good validation data for what's happening on the ground, as well as the actual image stack that you're hoping to apply the pyNITA algorithm to writ large. So the starting point for me is in ArcGIS, but of course you can do this elsewhere. But basically, you're going to want to assemble a set of well-known points first. And so we're focusing in here on some oil palm plantations. This is in Papua, Indonesia. And so this is an area that we know has had some change, as you're seeing here, from primary forest to oil plantation. And so these points were laid down in order to capture sort of the range of changes that are being seen on the landscape, and some points that are no change in order to kind of calibrate and validate pyNITA. So I'm not going to go into how to make a shapefile and all that. This is kind of a prerequisite that you could do, QGIS, or I guess it's Q now, or ArcGIS. But the basic idea is the same, that you just need to make however many points you want that cover a range of values that you hope that NITA can track, making sure to both put in change and no change classes if the latter exists. And the key kind of housekeeping here is that you're going to need to have explicitly an object ID column. So that does come automatically with a feature class in a geodatabase, but if you're just using a shapefile, you will have to add this yourself. So an object ID that can really just be, it's any unique numeric ID for your points. And then also a name column, and please do use these exact spellings and whatnot for right now. It'll just make your life easier. And the name column is just a description of what you're seeing to remind yourself later on. So I've added 25 points here that are, again, under a range of conditions. So the other thing will be the actual, just a single polygon that outlines the area that you'll want to get the image stack for. So usually this will be like larger than your set of sample points. In this case, this is just to match up with the demo data set that comes with pyNITA. And so it's a lot smaller in order to make sure that the processing goes quite quickly. And so you can see that in the right part of the image is some evidence of disturbance, and on the left part you have intact forest. And as far as making the polygon, you really just draw a single polygon, and you do not need to add any attributes. So pretty straightforward. So once you have these two shapefiles created, you then go to Google Earth Engine. So this, again, there's a little bit of pre-work for you here, in that if you don't have an account set up through code.earthengine.google.com, if you're not a Google Earth Engine user, you should become one. Could be useful for other stuff too. They got a lot of data and easy global remote sensing processing available. But for our case, you just need to sign up, and then you need to follow a couple simple steps that using scripts that we are providing. So there's no real no coding involved in this process. So these scripts are going to be available. These are in the supplementary materials, which you've probably already found if you're watching this video. But we've got the export Landsat samples is the first one, which is deals with the points, and the dates images is the final image stack. So before actually running these scripts, you're going to have to upload those files. So in order to upload the shapefile. In the Assets tab, you'll go to New, Shapefile, and this is where you can first see the elements of the shapefile that you actually need. So a shapefile is actually like around 6 components, 4 of which are required to upload here, or a full zip file. That might be easier for you. So I'm going to call this Papua Oil Palm Points 2 because I've already uploaded this before, and I'll grab my files here. So Papua Oil Palm, not poly. So we got points, we got the projection file, the shape file, the table, and I am just missing the SHX down there. So those are the 4 required elements, and you can review those here. Go ahead and upload, and you can see now over in this Tasks tab, you can watch it uploading. And then you would do the exact same thing for the poly file. So I won't do that right now because I've already done it. So you'd wait for that. That would take, a couple minutes to upload depending on how large it is. You can refresh your browser if you see fit. And then once that is good to go, you can go ahead and run the code. So to do this samples, you'll need to direct the code towards your points. But let me step back and introduce the code a little bit. So again, you don't need to do anything other than make some quick changes to the red text in this user inputs area. Everything else just runs on its own. But the upshot is that you're kind of defining your study area, gathering image, cloud masking, and cross-calibrating. And the cross-calibration is between Landsat ETM and Landsat 8. So here's some specifics on that cross-calibration, including the paper that describes it. The algorithm is, gathering the spectral bands and then calculating spectral metrics. And so here you can see where NDVI and MBR are calculated. So you could see where if you wanted to get creative, you could add in a couple more lines of code to create additional VIs. And then you've got an output to a CSV. By default, that goes to Google Drive. So let's run this. So I've updated, it knows where this file is in my assets. You can define the start year and the end year. So let's update this to 2020, January 1st, 0605. It's just going to grab all of the images in there. So that's all I need to do. And then I can run this guy. And you can see the tasks light up. You can also see that the points have ended up in the appropriate place down in West Papua. So that is heartening. And you go over to the tasks, and then you actually have to run it and make a useful name for the output that will end up in Google Drive. Just give it my initials. You don't need to rename that if you don't want to. It doesn't matter. And we'll run that. And so keep in mind that if you are doing even points over a large area, that can really take a long time to process because it's kind of based on the bounding box of the points as to how much imagery the servers need to grab. So for a small area like this, it doesn't take very long, but global, even if you have 4 points across the globe, it could take a really long time to do this. So you might want to divide up regionally. So we'll let that guy go. Actually, I'll just stop it because I already have the output. So we can look at that in the CSV form in a little bit. But on to the images, I will abandon my changes. That's fine. Okay, so now we're in the Landsat dates and images. And so again, you can see here that I just have the polygon that I uploaded instead of the points. The dates are already good, 1980 to 2020, and the underlying code is pretty much the same. It just outputs in a TIFF format instead of CSV. So I would go ahead and then run this one, and you can see it creates three files: stack dates, that's a CSV of the dates that align with the images, and then an NDVI stack and an NBR stack. So probably prepend this with Papua oil palm and then copy that for speed. All right, so those are all running and will eventually be ready to grab in Google Drive. And from Google Drive, you just need to put them into whatever your working folder will be for pyNITA.